General Introduction. The application in an ecological context of the economic and sociocultural concept of goods and services has been developed as a response to environmental degradation and the need to pay more attention to ecosystem functions and biodiversity in international policy. Loss of natural values due to human activities was recognized already long ago as a drawback not only for environmental quality but also for economic and social welfare. In the traditional economic theory, these were defined as negative external effects. In the course of the 20th century, research started to quantify environmental impacts in economic terms, to include impacts in market decisions. This turned out to be complicated because environmental impacts were difficult to quantify and it was criticized because of market imperfections. It was recognized that more attention needed to be given to ecosystem functions in order to link economy and ecology, de Groot 1987. Ecosystem functions can be considered as the basis for the goods and services the ecosystems deliver to society. These ecosystem functions can be defined as the capacity of natural processes and components to provide goods and services that satisfy human needs, directly or indirectly, de Groot et al. 2002. In this definition, ecosystem functions are explicitly coupled to human needs, rather than internal ecological processes, implying that ecosystem functions provide the goods and services that are valued by humans. Figure 1. Figure 1. 1. Ecosystem structure and process. 2. Ecosystem functions. 2.1. Regulation. 2.2. Habitat. 2.3. Production. 2.4. Information. 3. Ecosystem goods and services. 4. Ecological values, based on ecological sustainability. 5. Socio-cultural values, based on equity and cultural perceptions. 6. Economic values, based on efficiency and cost-effectiveness. 7. Total value. 8. Decision-making process to determine policy options and management measures. Figure 1. Framework for the integrated assessment and valuation of ecosystem functions, goods, and services. De Groot et al. 2002. Meanwhile, methodology has further been developed to express the goods and services in monetary values. Costanza et al. 1997. Pimentel and Wilson 1997. The concept of ecosystem functions has been used as a basis for policy development. In the Convention on Biological Diversity, CBD, agreed upon at the Earth Summit in Rio, 1992, the ecosystem approach was adopted as a basis for international policy. It stands for a holistic approach in environmental policy, including environmental, economic, and social impacts of developments on the short and long terms. At the Johannesburg World Summit, 2002, the ecosystem approach was endorsed as a basis for the CBD, so the ecosystem approach stands for the ecosystem functions as a basis for ecosystem goods and services. As stated by Beaumont et al. 2007, the ecosystem goods and services concept provides a method to ensure the integration of environmental, economic, and social demands and pressures. Goods and services are defined as the direct and indirect benefits people obtain from ecosystems. Beaumont et al. 2007. Assessing ecological processes and resources in terms of the goods and services translates the complexity of the environment into a series of functions. The concept has been further developed in the framework of the Millennium Ecosystem Assessment, MEA 2005. In the MEA approach, ecosystem goods and services are divided into provisioning, regulating, supportive, and cultural services, where supportive stands for habitats and genetic diversity. Many studies have been carried out on quantification of the ecosystem goods and services in the project The Economics of Ecosystems and Biodiversity, TEEB 2010. It is a global initiative focused on making nature's values visible. Its principal objective is to mainstream the values of biodiversity and ecosystem services into decision-making at all levels. It aims to achieve this goal by following a structured approach to valuation that helps decision-makers recognize the wide range of benefits provided by ecosystems and biodiversity, demonstrate their values in economic terms, and, where appropriate, suggest how to capture those values in decision-making. www.teebweb.org The ecosystem goods and services concept is promoted as a basis for decision-making that now has a methodology to include not only an integrated approach to human impacts on the environment but also to evaluate the services that ecosystems provide for human use. This can be considered as a paradigm shift in environmental management. From a focus on adverse impacts, now ecosystem functions and their benefits for society can be analyzed, quantified, and evaluated in more detail. This is of particular relevance for bivalve aquaculture. Farming of bivalves is an extensive type of aquaculture as the natural environment generally provides feed, seed, and space. Bivalve farming makes use of nature but also depends on nature. The close link between bivalve culture and nature has posed questions about possible negative impacts. In fact, these questions are dominant topics in many public debates all over the world. It is about impacts on habitats, landscape, sediment, carrying capacity, and other users, resulting in competing claims. Yet the ecological role of bivalves in the ecosystem provides a suite of goods and services to society. This has not yet been addressed in scientific literature in a comprehensive way. Reviews are available on specific ecosystem functions that exemplify the relevance of the concept. Cohen et al. 2011. Ferreira and Bricker 2015. Peterson et al. 2015. Yet many questions remain to be addressed. A part of these deals with the discussion on the goods and services concept in broader sense, such as the debate about valorization in monetary units. See TEEB 2010. The aim of this book is to review and analyze the goods and services of bivalve shellfish. Given the debate about the different types of goods and services and their content, Haynes, Young and Potchin 2017. We included bivalve habitats in the section on regulation and did not address a separate section on supportive functions. So, the papers have been ordered as provisioning, regulating, and cultural services, and there is a separate section on the assessment of services. Odd C. Small, Wageningen Marine Research and Aquaculture and Fisheries Group. Wageningen University and Research, Yerseke, the Netherlands. Odd.small at wer.nl. References. 1. Beaumont N.J., Austin M.C., Atkins J.P., Burden D., Degraer S., Denchino T.P., Duras S., Home P., Horton T., Van Ierland E., Marbo H., Starkey D.J., Townsend M., Zerzitsky T., 2007. Identification, definition and quantification of goods and services provided by marine biodiversity. Implications for the ecosystem approach. Mar Pollute Bull 54, 253-265. 2. Cohen L.D., Dumbald B.R., Judge M.L., 2011. Expanding Shellfish Aquaculture. A review of the ecological services provided by and impacts of native and cultured bivalves in shellfish-dominated ecosystems. In Shumway S.E., ed., Shellfish Aquaculture and the Environment. Wiley Blackwell Sussex, United Kingdom, pp. 239-296. 3. Costanza R., Darge R., De Groot R.S., Farber S., Grasso M., Hannon B., Limburg K., Naeem S., O'Neill R.V., Peruelo J., Raskin R.G., Sutton P., Van den Belt M., 1997. The Value of the World's Ecosystem Services and Natural Capital. Nature 387, 253-260. 4. De Groot R.S., 1987. Environmental Functions as a Unifying Concept for Ecology and Economics. Environmentalist 7, 2, 105-109. 5. De Groot R.S., Wilson M.A., Boumans R.M.J., 1992. A Typology for the Classification, Description and Valuation of Ecosystem Functions, Goods and Services. Econ 41, 393-408. 6. Ferreira J.G., Bricker S.B., 2016. Goods and Services of Extensive Aquaculture, Shellfish Culture and Nutrient Trading. Aquac Int 24, 3, 803-825. 7. Haynes Young R., Potchin M., 2017. Common International Classification of Ecosystem Services, CICES. V 5.1, Guidance on the Application of the Revised Structure. Fabi Consulting Limited, Nottingham. 8. Millennium Ecosystem Assessment, 2005. Ecosystems and Human Well-Being, Synthesis. Island Press, Washington, D.C. 9. Peterson J.K., Sorrell C., Nielsen P., Timmerman K., 2016. The Use of Shellfish for Eutrophication Control. Aquacult Internat 24, 3, 857-878. 10. Pimentel D., Wilson C., 1997. Economic and Environmental Benefits of Biodiversity. Bioscience 47, 11, 747-758. 11. TEEB, 2010. The Economics of Ecosystems and Biodiversity Ecological and Economic Foundations. In Pushpam K., ed. EarthScan, London, Washington, D.C.